Welcome to java9s.com. I'm Srinivas. In this session, I'm going to teach you about Java operators and assignment operators. There are different types of operators. There are arithmetic operators, bitwise operators, conditional operators, increment operators, shift operators, assignment operators. Coming to the arithmetic operators, you can find addition, subtraction, multiplication, division, and take remainder operator. And I don't need to teach much about these things as they are very basic. Coming to the bitwise operators, you can find the bitwise OR, bitwise AND, bitwise NOT, and bitwise exclusive OR. Let us see the truth tables of these bitwise operators. When you see the bitwise operator OR, you can find that if any one of these bits is 1, then the result is going to be 1, and if both the bits are 0, then the end result is going to be 0. And then coming to AND operator, if any one of the bits is going to be 0, then the end result is going to be 0. And the NOT is just about flipping 1 to 0 and 0 to 1. And coming to the exclusive OR, please remember in XOR, both the bits have to be different to give our end result as 1. So you can see that 1 0 and 0 1 is giving 1 as the result, and if both the bits are the same, then it is giving the end result as 0. I have just applied these bitwise operators to numbers like 120 and 25. Coming to the OR, you can see that when I apply OR for 120 and 25, I'm getting 121 here, because at least 1 is present here. I'm getting the end result as 1, and wherever I see 1, the result is going to be 1 here. So I got the end result as 121. And coming to AND, for the same numbers, I got 24 as the result. You can see that if you find 0 in any place, you can find the end result is going to be 0. So the next one is exclusive OR. Its principle is that both the bits have to be different to give the result as 1. So you can find that the first set is different, so we got the end result as 1, whereas these things are the same, so we got the result as 0 here. When I apply these to 120 and 25, I got the result as 97. And when you apply bitwise NOT for the 120, I'm getting the minus 121. You can see that MSB is 1, so it's going to be a negative number. Coming to the conditional operators, you can find greater than, less than, equals, not equals, instance of, less than or equal to, greater than or equal to, short circuit and short circuit OR. So I'm going to only talk about the equals, instance of, and short circuit operators. Rest of all are very basic things. Coming to the equals, when you apply the equals operator to primitive data types, it is going to compare the bit pattern that is there in the variables and give us the result. Say I have declared int x is equal to 20 here and int z is equal to 20, and I'm using equals operator here. So this will compare the bit pattern that is there in the x and compare the bit pattern that is there in the z, and then it gives the result as true. But when you apply the same operator to the objects, say I have created an object known as car C is equal to new car, and I gave the same memory address to another reference known as B, car B is equal to C, and when I use this equals operator, this returns true. Please remember that the equals operator will not compare the contents of the object, it's just going to compare the memory address. So when we get B is equal to C, then it means that B and C are actually referring to the same object. That doesn't mean that the contents are also same. So to compare the contents of the object, we have to rely on equals method that we will be discussing in future session. And coming to the conditional or operator instance of, this can be used to check if an reference is a type of a particular class type or an interface type. Say I have a class known as class car, and I have created an object car C is equal to new car. I can use instance of to check if the C is an type of vehicle or C is a type of car. This will return true for both the conditions. So instance of can be used to check whether a particular reference variable is a type of a class type or an instance type, interface type. Coming to the short circuit and or, when you use short circuit and, here you can see that I have used a statement 5 greater than 6, which is going to be false. When the first statement itself is false, the short circuit and will not check the second statement, because anyway the total condition is going to be false. So using short circuit and will reduce the execution of more conditional statements. If the condition fails at the initial level itself, then short circuit and will not take the responsibility of going for the second statement. In the same fashion, if you give the right statement, say 7 is greater than 5, which is going to be true, then the short circuit and will go and check for the second condition if it is true or not. If it is going to be false, then the total condition is going to be false. Coming to the short circuit or, here I have used the first statement 7 greater than 5 is going to be true. So if any one of the conditions is true, then obviously the OR is going to return true. So here the OR will not check for the second statement whether it is true or false. Anyway, the first one is true, so it will return the total condition as true. If you put the false statement in the first place, then OR will go for the checking the second statement again. You can use a single and or but whatever you have seen as bitwise operator, you can use that in the checking for the conditions also, but the problem is that it checks for both the statements unnecessarily. So short circuit and or will give better performance when compared to say and or when used in the conditional statements. Coming to the increment operators, we have increment operator and decrement operator. These operators can be used to increment a value by 1 or decrement a value by 1. This can be used in two flavors. One is an postfix operator, and the other one is an prefix operator. Let us see about postfix increment operator. I have declared an value int x is equal to 20, and the other statement is int b is equal to 40 into x plus plus. Here you can see that for x I have applied the postfix operator. That means that once the statement comes to the execution, the value of x will be used first, and then once the statement is over, the x will be incremented. That means postfix means it will be incremented after the value of x is used in the expression. Whereas when it comes to prefix, you can see that in the second statement I have used prefix operator for x. So here first the value of x will be incremented and then it will be used in the expression. So here you get 800 and here you get 840 as an result. Coming to the shift operators, these operators will work on binary bits. So first one is a right shift operator, the second one is a left shift operator, and the third one is the unsigned right shift operator. When it comes to first one, right shift operator, I have, for example, I have declared byte b is equal to 120, and I am saying byte c is equal to b to the right shift of 3. That means I am telling to shift the bits of 120 to 3 positions towards right side. So if you see my binary pattern of 120 is something like this, and when I shift all the operators towards right side to 3 places, I am getting the result as 15. Please remember that when you're using right shift operator, when you have the MSB as 0, then the 0 will be replaced everywhere. If you find 1 here, then 1 will be replaced everywhere whenever the bits are moving towards right. So with the right shift operator, if you have 1, then the negative symbol will always be preserved. Then coming to the left shift operator, you are using left shift operator, you're telling the bits to move towards the left hand side. So all the bits that are there on the right hand side will be replaced with 0, and all the bits will be moving towards the left hand side. Here you cannot predict what kind of symbol is going to come, depends on the end result. So you can see here for a positive number I got minus 64 as a result. And coming to the unsigned right shift operator is very similar to the right shift operator, except in one case that if there is 1 in the most significant bit area, then 0 will be replaced every time. So even a negative number will fetch a positive number for unsigned right shift operator. And the last section is the assignment operators. Whatever the operators we have seen, you can see them here with an equals operator. So it's just calculate the result and assign to the variable that is being used. So all these are assignment operators. That's all for this session. You can find an example at java9s.com. Thank you.